Okay, class, welcome to data management. This is our first lesson in data management. It's actually only on the first learning goal, and so it's just really getting into the ideas. And so the point of today was really just to introduce you to the concepts of probability. So we are going to have a couple definitions today, but the main thing that we really want to just get certain is why do we need probability? And just to kind of hook you into the course and let you know the power of probability. And we're going to also start talking about some of the big concepts that we're going to cover in the first half of the course. So this is a quote from Rene Descartes. It is certain that when it is not in our power to determine what is true, we ought to act according to what is most probable. And so this is one of the big ideas of the course, really. This quote is that there's like the concepts of probability really help us to make decisions. So the big idea, and this is going to be really the big idea for the first half of the course, but really for the whole course. But tools from probability allow us to help get more information so we can make decisions and manage risk. For today and tomorrow, we're just learning terminology and basic components, the definitions of theoretical probability, so that we can use them for more complex problems. So the point of this video here, and you can click on it if you want to, but just the point of this video is just to show the amount of money that casinos have. So the amount of money that they have to kind of put you up in hotels and treat you like a VIP. And so the question is so one of the big things we're going to talk about in the first half of the course is really what gambling and casinos, how they all run. And so the first thing we want to kind of talk about though is where does when you go to put money into a lottery or a casino, where does that money actually go to? And so this is right from their website. It's provincial hospitals, sport, recreational, cultural activities. So it does a whole bunch of important things, but you start to realize that these are the kind of things that taxes pay for. And indeed, the revenue that from the government is a tax. So that's how they get money from us. But it's an optional tax. And so it's something to reflect on. And so it's an optional tax that we can opt into, but they're certainly always going to be making money for it. How casinos work, this is a nice explanation of how casinos work, and a whole bunch of people are putting money in, and then some people get it out, but then the casino takes really more than they give out. And so a concept that is important is this idea of expected value. And so expected value is as a definition, if you want to get into your notes, is a value that a game costs the operator per trial based on prize amount and probability. And so there's an example of rolling 2 dice that we're going to talk about in a second. But let's look at rolling 2 dice. And so we played a game. We're actually going to play a game in class where you just give yourself a point if you guess correct. And so we just roll 2 dice, and so the idea is, can you see which ones are more likely? What it gets to is this idea that 7 is actually the most likely to come up because there's all these combinations of ways to get a 7. You can roll a 6 and a 1, a 5 and a 2, a 4 and a 3, and that's how this chart works. And it's a really helpful chart to talk about probability of rolling 2 dice. And so we'll kind of answer these questions in class. But they all come out of this little chart here. It looks almost like a times table and a multiplication table. And there's actually 36 outcomes, and all of the numbers out of 36. Some definitions to get down. Experimental probability is probability based on trials. And so this way of writing probability we're going to get used to. It's kind of like function notation from grade 11. Where the function n counts the number of times, and p is the probability of an event. A is what we kind of talk about. We use b as well as the outcome, and then t is the number of trials that happen. So we explore this more in class in some examples. And theoretical probability is all of the different possible outcomes. So you notice that the formula only changed. Instead of doing something divided by something being the number of times successful, and then the number of times that you did it. Here it's the number of times that successful possibilities, and then the number of times that you could possibly do it. So all the different possible outcomes. And so S we call the sample space, all the different possible outcomes. It's helpful, like just as we model it in class, exactly how we're going to use these terms, and they kind of pave the way for more complicated probability in the future. Subjective probability we just kind of give as an idea, because like things like the weather and odds for your favorite team winning the World Series, the Super Bowl, like these are all subjective probability. It's a little bit different. It's not something that we talk about in this class. It's based on intuition or professional. We don't necessarily use mathematical data. We do, but based on like previous outcomes or something like that. But there's a subjective component to it. So I just want to talk about that so that you know, okay, what is percentage of precipitation? We're going to be using subjective probabilities for different things, but like we can't actually calculate those. They might be given to us, and we might use them, but we can't actually calculate them. So here's a question that is kind of interesting to ask, and it's kind of based on that idea of just rolling the two dice that we just talked about. So if you win, if you roll a sum of 5, and so you can go back to the table, you can see those really 4 outcomes for rolling a 5 out of 36. But the question is, how much would you expect this to cost the person giving out the $100 every time a 5 is rolled, if it was rolled 36 times? And then the question is one time. And so that's really the idea of expected value, is that one time, because that helps you figure out what the operator would charge. So if you think about this for a while, you realize that there's $400 given out every 36 times. And so if we divide 400 by 36, we figure out what it is per, and then we just charge more than that. And that's basically how things work. So that same idea, like you can try with this question. If you had a game that pays $100 for drawing an ace out of a deck of 52 cards, you might have to look up what cards are, and just a Google image search of a deck of cards would show you that there's 4 aces out of 52 cards. And you could ask the question like, how much are you going to charge? And that's basically how games work. And we're going to keep having that conversation throughout the first half of this course. And so then there's some homework from the textbook.